Hi everyone, welcome to Sales and Marketing Call Center Analysis using Python. In today's video, we're going to be creating what you can see right on your screen. So if you want to actually use Python to analyze data, this particular video and my other videos plus these subsequent videos to come will definitely help you understand how to use Python to answer business questions or any data set you have at all. So all you have to do is to make sure you follow me on this particular series and learn how to use Python to analyze call center data. So make sure you download the data we're going to be using for this particular project and follow me step by step for we to create it together. Don't forget to subscribe, like, share, and actually leave a comment. So see you in the class. So our data set is about sales and marketing call center. And those are the questions we're going to be using Python to answer today. So we have this particular questions here, which says agent performance analysis. And the first question says, who are the top performing, agents based on agent rating? So the top performing agents based on agent ratings. So this is exactly what we're going to be treating first before we come into this particular one. So let's do it. So the very first thing you have to do, if you have not installed Python on your machine, just go ahead and actually install Anaconda. Then you search for Anaconda, and I'm going to give you this particular Anaconda navigator right here. So if you have it opened up, it's going to give you something that looks like this. All you have to do is to look for Jupyter Notebook, which is this particular one. So if you go over here right now, you can actually filter to those installed applications for you, and it will only give you those installed applications. Then you can quickly figure out where this particular Jupyter Notebook is sitting. So go ahead and launch it. All right, once you have it launched, it's just going to give you something that looks like this. So what it's showing me right now is all the files on my PC. So I want to actually open a folder inside the desktop here. This is my desktop. I'm going to double click it. So once I've done that, just go to new over here, click on new folder. So a new folder has been inserted. I'm going to name the folder to Call Center Analysis. So we now have a folder right now. Inside this particular folder is blank. If I have it open again, now there is nothing here. So we have to actually prepare the environment where we're going to start writing our code to analyze the call center data that we have. So go over here again. And now click on this particular Python that has Conda here. So here you go. You have something blank as this. Double click on it. All right. This is what you're going to have. So we call this one here is cell. That is where you actually start typing your Python code. So the very first thing you have to do is to make sure you title this particular one. So it's on title. Click on it and just call this one. Let's go back here. So we're going to title it after this. You can copy this one from here. So O1. So I'm going to paste it in here and click on rename. So this gives us agent performance analysis. This is what we're about to do right now. So before we go on, we have to actually import some couple of libraries we're going to be using throughout the class. It's very important. So let me show you how to do it. So over here, I'm just going to come here and use this particular markdown. So put a hash key. Now over here, I'm going to do importing libraries. So hold your control key and hit the enter key. So you're going to have something like this. The next thing you have to do is to actually enter some kind of a couple of cells. So if I hold my shift key now and hit my enter key, I can actually enter as many cells as I want, right? So let us start, importing those particular libraries we're going to be working with. The very first one is going to be pandas. So import pandas as PD. So the next one is going to be numpy. So import numpy as NP. So the next one I'm going to be using is going to be seaborn. So import seaborn as SNS. So try to remember all of this. So this is the most important one among them all. So we're going to import this particular matplotlib here. So .py plot as plt. So those are the libraries we're going to be working with. So the next thing right now is to connect to our data. So connecting to data, quickly you can come over here and just make sure you have it bold. So Control Enter. So you have this. So let us now connect to our data. So the data you have downloaded from me is what you're going to be connecting with. The very first thing you have to do is for you to make sure you go back to the folder where you have the data saved right in. So here comes the data you downloaded called Sales and Marketing Call Center. So if I now go over to copy path right here, I can copy the path to this particular file, right? It has been copied. Let me step up from here. So coming over here right now, we can actually do here file underscore path. You can name it whatever you like. So it's just a variable to store something right in. So over here inside parentheses, I'm going to put in or paste in this right in here. So for now, it's not going to work. If I hold my control key and hit my enter right now, it's going to give me this particular error. To bypass this particular error, let's come over here and put R. And now if I run this now, there will be nothing displayed, which means I'm good to go, right? So let's see. Let us create some kind of data frame. So for the data frame here, I'm going to do df, and the df is going to be equals pd.read underscore csv. So our file is actually a CSV. We do that. So we're going to actually make sure we bring in the file path, which is the path we just created over here into here. So underscore path. So nothing happens. So let's see if we run this now. I think we have it is not found. Let's go here. We should have PD here. Okay, so let me see. What if I just copy all of this here, Ctrl X, and have it right in here? Let's see what's going to happen. So if I now run this now, so it works. So which means I can't separate it. So we're going to use this one for something else. So instead of us having this now, this particular part here, I will just use normal comment in here to data. So just always leave this. So if you want to delete your cell now, what you're going to do is to click over here, and the cell has been deleted. So including this particular one, you can just go ahead and have it deleted like this, right? So this is working fine. If I now set df right here and hold my control key to run this by hitting the enter key, it should display the whole data right here for me. Okay, now as you can see, I have all the data right here. So you can see over here, we have 17 columns and 20,000 rows. I think, 200,000 rows. Wow, that is huge, right? This is what we actually have. So if you look at here right now, we have this particular part that looks like dash, dash, dash. It's just like, I don't know how to put this to you. Python is just limiting some rows. It's just giving us some default numbers of rows. It's not a problem. So it's not a problem right here. Don't get freaked about it. So one thing I love to do always is I love to display my data just like the way Excel will display it. So how do you do that? Let's come over here. So if we are here now, dismiss. So we can click on desktop here. So when we click on desktop, our data is on call center. So call center Python class, double click it. So this is it here. If I go ahead and double click this right now, so as you can see, now it has been opened. Comparing to this particular one right here, this is not giving me something very much more better than this one. So I love this one here. You can actually scroll through to see your columns that you're going to work with, right? Okay, this is exactly what it is right in here. So we're going to be working here. We have connected to this data and it's working fine. For this time, we just have to take off this, Control Enter. So we'll run it to actually get off that because we're not interested in displaying that. Okay, let us start and look at what the first question is all about. So this is our question here. So how do we solve this question? Remember, this particular part here is your data frame. The data frame is just like we have this particular whole table right inside here. So whenever we call df, we can actually reference any of the columns we have right in here and perform analysis right on the column. You get it right now? So let us look at what we are going to do. So the very first thing we have to do, if we go back over here right now, you can now see that we have the agent first name and the agent last name right here. So let us see how we can actually combine those particular two names together. It's very, very important. So over here right now, what I'm going to do is just to do df. I told you this is your data frame, right? So now we're going to actually add another name into our data frame. So how do we go ahead and do that? So to add another name, another column now. So inside this particular square bracket, we are going to do agent underscore full underscore name, right? So now this is a column we are adding. It's a new column we are actually adding to our data frame. So with this now, I'm going to say equals df again. So this particular df is actually telling Python that we have a column, and the column that exists right here, if we go back here now, is this particular first name and last name here. So we're going to say here agent underscore first underscore name, right? So this is exactly what we want. So I can copy this one to make it speedy. So once I have gotten this done now, the next thing I'm going to do is just to make sure I say plus. So plus over here. So what this plus is going to do is just actually join the two together. So I'm going to actually look for a delimiter. The delimiter should be space like this, right? This is the space delimiter. I'm going to do another plus again, and I'm going to paste in this one. And instead of me to say first name again, I'm going to do last name. So you have to make sure this is correct. So if we have done this now, let us run this and take a look at what it will give us. df here. So let us go straight up to this particular part. So if you can now see here, we have agent full name right in here, and it has been combined together, but we have an issue. The first and the last name is being combined together without any delimiter. So which means this here should be, you just press your space bar. And now we run this. By clicking over here, you can rerun this, right? Let us verify that. So it works. We now have space between the names right now. So this is the first thing we have to do, right? So we have just combined the first and as well the last name put together, which is something very, very important. Okay, the next thing we have to do right now is that we want to actually convert. I think I love using comment a lot to tell what every single line of code is doing. So I can just say here So once I've done now, the next thing is for we to actually write a particular code that will definitely convert the agent rating to numeric value. So over here, you just have to leave a comment. So to do that now, what we need to do is just to know the name of the column we are going to deal with. That was why I have this open right here. So if we come over here right now, we have agent rating here. The agent rating is actually the rating given to every single agent for every single calls they received or the calls that were some kind of failed. Now for where you have blanks right in here, those are calls that were abandoned because there was no connection between the caller and the agent. So there was no any rating, right? So that is it. So if we go back over here right now, we can now see over here, we have df, that's our data frame. Inside this particular df, we want to actually say we have what we call agent underscore rating, right? So this particular agent rating, we're going to say equals, so pd dot to underscore numeric. So we open the bracket here, or parentheses, df. I'm going to explain this again. So over here, we're going to do agent underscore rating again. So make sure if it is on uppercase, do that, otherwise you're going to have an error. So rating and comma here, sorry, the comma should come over here, errors equals here. So we close. Okay, let us see what will this particular line of code do right here. It's very important for you to understand this particular line of code. So if you look at it now, we have this particular pd dot to numeric right in here. So what this does is actually helping you to some kind of convert the agent rating into a data type that is actually a float, right? Or a float or decimal number. So another important part of it again is this particular error part right here. This error part, what it does is this: if there is any column that is actually NA or missing value, it can actually cause an issue. So automatically Python is going to actually handle that for you not to actually have any error. So it's always very important for you to do this, right? So this is what we need to do right here. So if we look at the question critically again, it says who are the top performing agents based on agent rating. So what are we going to base the top performers on right now? So on my own case, I would love to base the top performing agents based on agents with the highest ratings above 4 or highest rating like 5, right? Any agent who is rated 5 would actually fall into this particular bucket. So which means right now I'm going to actually filter and display only agents with 5 ratings from colors. So let's see how we can actually do that. So what I'm going to do right now is just to actually say here, let's do highest underscore ratings. So df here and that df again. So we're going to call this particular agent rating column that we actually have. So agent rating that we have here. So we are going to check that and see if it is actually equals. So when you want to see, or when you want to check if something is equals, 1 equals, no, will not do it. You have to do double equals. So if it is equals to 5, I'm going to do 5.0, right? So if that is true right now, what I need to do here is just to say, okay, agent full name underscore full name. If you remember this is actually what we added to our data frame. If I go over here now, you can see agent full name. We got it displayed and it's actually right on our data frame right now. So we're going to do it by agent full name. So here I'm going to say comma agent underscore rating, right? So we go outside here, trying to look at something. So over here, this okay, so we have to open another bracket here and we have it close over here. So we're going to do this one to the dot drop underscore duplicate. So here we go. So this is what we actually have right now. So before we show the result, let us look at what this particular highest rating here is actually doing. The highest rating here is actually checking the data frame and see if truly we have a column called agent underscore rating. And we want to actually filter to where we have 4.0 or sorry, 5.0 or just 5. That is exactly what we want to do. This means, you know, our highest rating will now be selected, and it's only going to be equals to this particular 5 right here. So once we have done that, we actually try to like say, okay, we want to display this based on agent full name, and the agent rating here is actually going to show their ratings. That is exactly what we want. So quickly, this is the variable we're going to look at how this will show up. Let's see this. So if you look at it right now, we have this right here. Can you see it now? For all the agents that actually has rating that is actually 5, this is what we have right here. So if I do here to be 4.0 and I just try to run this right now, you can see it has changed to agents that has 4.0. It's exactly what it is. I'm going to keep it at 5. So 5 is the highest. So we just have this over here. So that is the first question that we have just answered, and it is something very, very simple, right? So I believe you can relate to what we have done right here. If you have not actually subscribed to my channel, please do that. And as well, if you have not liked this particular video, go ahead and do it, and make sure you share it to your friends and family. So let's go into the second question. The second question says, what is the advantage? Oh, sorry. The second question says, what is the average call duration by agents? That is exactly what we're going to treat right now. All right, here comes the second question right here. On the second question, we are looking at the average call duration by each agent, right? So how do we go ahead and do this? It's something very simple. Okay, if I go all the way up right now, if you remember what we have done right here, over here, we actually try to convert agent rating to numeric value, right? So, if we go over to here and look at the question again, it says, what is the average call duration by each agent? So call duration, now we have to go over here and try to look at if we have any column that supports that. So we have a column here called call durations in minutes, 10 minutes, 26 minutes, 22 seconds, 10 to 2. And where we have 0 is where the calls were abandoned, which means the call were not picked for a particular reason. I don't know. So now this is what we want. So first of all, to actually have what we want to do done easily, we have to quickly convert this into numeric value. I don't know, maybe I should actually copy from here. We can copy this particular one we have actually typed in before and go over here and just make sure we do the right thing. So convert, agent call duration. Here is going to be call duration to numeric value. So instead of us to show call agent here, we rather show here. So it's going to be call underscore duration underscore minutes, right? So this is going to be this is going to be equals pd dot to numeric. We're still going to use the same thing. The df here is going to be the same thing. This time around, we are going to repeat this same thing we have over here, right? We're going to repeat it again inside here. So we paste this one over here. So this is what we need to do, right? This is exactly what we need to do. So what we have just done is to convert this into numeric value. It's very important. You should actually get this done. Okay. Now, the next thing we have to do is to actually go ahead and create the average call duration. So here we're going to do to calculate the average call duration. To calculate the average call duration right now, avg for average underscore call underscore duration. I always want to use small letters. Duration, so equals df dot group by. So what we're going to do right now is just that we want to group by the agent full name. We don't have to define this again. We already have a particular line of code that actually did that for us right here. The first line of code we wrote after we connected to our data, the libraries. So we're going to use that. So we're going to be grouping it by the agent. So here, agent underscore full underscore name. You get it right now? So once we have done this now, the next thing we have to do is to actually come out of it and do here. We can call this again. Can you see? You can just copy this to make it faster. So paste it over here, right? So over here, we're gonna do dot min. So this is what we need to do. Let us try to run what this will give us now. So this is going to give us something like this. Can you see now? We have just run the code and it's giving us this 18.6, 15.5, 0.6, 15.63, 0.65 here. Okay, this is nice. So what if we think of rounding this? I think that's going to be very much more better, right? So what do? We come after this particular min here, we put dot round. So what are we rounding this? I'm going to round this by 2 decimal number. I don't know. So let us round by 2. So if I run this now, can you see what we have? So we're going to have this. So we've just created this and this is exactly what we need to do. You get it right now? Okay, but if you look at this, it's not actually sorted, from the highest to the lowest value. So what if we now decide to sort it? Okay, to sort this now, we can actually remove this from here. So let us create a sorting. So sort call duration. So we're going to do sort underscore call underscore duration. So it's going to be equals. So to sort right now, we are going to actually call what we want to sort. This is our result. This result displayed right here. This is the variable that actually display the result for us. We can copy it and come over here, then paste this down. So once we have done this right now, we're going to do dot sort. This is the most important part of it. So values here. So we do by, so equals. So we are going to do this call duration. What we want to sort is actually this particular one right here. We sort by call duration. You get what I'm saying now? We sort by call duration. So call duration in minutes. We'll copy this and we'll come over here. We can go double quotes and we'll paste this one over here. So once we've done that, we can do ascending. Oh, sorry. You just have to step out of it. So we can do ascending equals false. So let us try to run this particular one here. Let's see what it will give us. Okay, we have an error. False is not actually good for this. Why is this giving us this error? I love Python sometimes in this particular case to actually tell you what is not found. It says name false is not defined. So the reason why it says false is not defined was because we are using small letter of it. So if I now turn this one to caps right now, it will now change. This is a function. It will now change to this particular color. Let us run this again. Okay, we have in that one got an unexpected keyword argument by. Okay, if you look at this right now, let us add something over here. So let us add here dot reset underscore index, and let's see if this will solve the problem. Okay, it does. So right now we have call duration in minutes. So if you look at this right now, this shows as a table, right? So if you now go ahead and say you want to print, and you do print, so here we print. So when you print, it's going to give you something like this. So plenty times if I'm doing something like this, I don't always do printing. What I do is just display, the result or the variable here without printing it, so that it can actually give me the feel of a table, just like this. Can you see now? Can you see? So what you might be thinking now is that, what if I actually go ahead and add a title to this? I think it's going to be very, very much important. So you can actually add a title to what we have here. So to do that now, you can come over at the end of this one here, step down. So here you can do print. So inside here, you can actually do all agents, average call duration in minutes. Okay, if I run this again, now here we have the title right in here. Can you see this now? So this is what we have. So what we have done now is just to answer this particular question here, where it says, what is the average call duration by each agent? So we have actually sorted it's 19.70, 19.56, 18.65, down to the lowest one, which is 15.58 right in here. All right, the next question says, which agents have the highest successful rate in closing calls? So what we're going to do right now is just do some kind of, I'm thinking. Okay, we're going to do percentage of successful call rating for every single agent. So, and we are going to use the previous codes we have used here. So if we come over here right now, I always love to remind you, it's our data frame, and our data frame here captures this particular whole data right in here. And we added, a particular column to it. And the column is actually called agent. You look at it here, agent full name here. So if we are going to reuse it, we don't have to call it again because we already have it above us. Okay. Now, the next thing we have to do right now is that we are only going to create for successful, right? Successful, calls. So we have to verify what column is that. So we have what we call call outcome. For call outcome, we have successful, we have failure, and we have abandoned. So we want to see which particular agent has the highest successful calls. So we're going to check the percentage and see who they are. So if we come back over here right now, we're going to create a filter to actually get this done. So don't forget to leave a comment. Filter only successful calls by agents. Okay, now to get that done right now, we can actually do a particular variable here, successful underscore calls. So for my successful calls right now, I'm going to do df and that df again. So we're going to actually look at the call outcome, which I've just seen recently. So we go ahead and say we have a column called call underscore outcome. So mind you, this is case sensitive. So we're going to say we want where, so putting this particular double equals here, where the call is actually success. So it was not successful here, it was just success. So here, success, we got it right. So that is what we want. Can we run this and see what it will give us? Let's see if this will make any sense. Okay, Now. We have agent name here, call outcome. Everything we have here is actually successful. We have just filtered our data to only where it is equals to successful, right? Okay, once we have done that right now, what is next? The next thing now is to calculate the successful rate per agent. So we're going to add a comment again. So calculate the success rates per agent. So here we can just do a variable called success underscore rate, right, equals. So to get that done now, inside parentheses, we're going to do successful. We're going to do a group by success underscore calls. That is going to be this variable here. So dot group by, this is not correct, group by over here. So what are we grouping this by? We are going to group this by the agent full name, so which is something we have actually created previously before now. If I go all the way up right here, we have the agent full name here. We don't have to redefine it again. So over here is going to be agent underscore full underscore name, right? So we do dot size. Okay. So we're going to divide this by df. So df, I think, group by, so agent full name again. So over here, we're going to do another one called dot size again. Okay, quickly, let us see the breakdown of what we have just written right here, right now. The very first thing is the variable right here, which is called success rate, right? So the success rate here is the variable, right? So we have successful calls grouped by agent full name, and we have size right here. So what it does is this: it groups the successful calls by agents and counts the number of successful calls per agent, right? It will count how many successful calls, Peter has, Greg or Mizan actually has. So it will actually count it. So after it has done that right now, we have a second one again where we have this particular part right here. So it will actually group calls, all calls, both successful and unsuccessful calls, right? This one here is only for successful. If you look at it right here now, it's a successful calls, right? It groups it to every single agent name's full name, right? And over here, we are not specifying if this is successful, failed, or abandoned. We're actually calculating for all the calls that actually came in, both successful and unsuccessful, so that we can actually make our division to have our, our rating. I don't know if you get what I'm trying to say right here, right? So let's see if we display this right now, what is going to happen. So we have an issue here. Success calls is not defined. Success calls. Oh, it seems we flopped a little bit here. This should be the same thing with this one. Let's copy and update this one here. Run this again. Okay, now you have this on a decimal. So we have to make sure we convert this and make it look much more better than this. So this should be, I'm trying to think. Okay, let's see how we can convert this to a percentage. So here we can do Okay, to have this particular conversion right now, we're gonna do success underscore rate underscore percentage equals. So we are going to do success rate. Our success rate now is this particular variable here. So we're going to copy it, we're going to put it right here, and I'm going to do dot apply. So we're going to use this particular lambda function. So X, I'm going to explain this. So the F string, and inside here, this particular curly bracket. So we do dot 2% here. So we have to close our curly bracket here. So what we have done here is actually using this particular, apply lambda here to convert this particular value here into a percentage. So let's see if I have this run now, what we're gonna have. So we can run this now. So when we run this, see we have this 19%, 20%, 20, 80-something% right in here, which is something very beautiful. And we have it for every single agent we have right in here. Okay, we're not done yet. What if we make sense with this by actually trying as much as we could to actually sort this? I don't know if you get what I'm saying. So we have to sort this. And if you look at it now, something is wrong. Over here, we actually have, agent full name, which is this one, but this one does not have any name right in here. So how do we actually name this? Let us look at how we can actually give a name to this particular column right in here. So to get that done now, we're gonna come here, and I will do reset index and rename column. Okay, now to get this done now, we're going to do success rate percentage. We can rename it with a different variable, or we can still use this particular same name right in here. So it's gonna be equals this again. So we're gonna do dot reset underscore index. So this is what you have to remember should you are creating a different project and you want to actually give a particular column a name. So you have to remember this particular line of code right in here. So our index now, we're gonna do name equals. So what name do we want to have for this particular percentages right in here? So we can actually do percentage of success. So it should actually go into single quotes. So percentage of success. And if I go ahead and run this now, so you can now see here, we have this. So you can name it whatever you like. If I decide to just go ahead and add rate now. So with that, we have percentage success rate. So if it doesn't make sense to you, you can rename it. So we're not done yet. This is actually good. We have actually, named that particular column. So what is left right now is to sort this. So how do we go ahead and do the sorting? It's very important. So let us do the sorting here. So to sort the percentage right now, we're still going to go ahead and call this particular, variable, which is this one right here, with this same variable over here. So once we call it, we're going to say equals. So we'll repeat it again. Now this time around, we'll do dot sort underscore values. So here we're going to do equals, I think by equals. We've done this before. It's something very simple. So by success rate. What is the success rate? We don't do success rate. We are doing percentage of success rate. You can copy this away from here, and over here, you can now paste in it here, right? So once we have done that, put a comma here, we can do ascending equals false. So let us try to run this and see what it will give us. Oh no, I'm gonna have an error. So I'm supposed to run this one, not this. Oh, okay. Okay, fine. We don't have to open this and close parentheses. So run this now. We should be good to go. Still again. False, 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 false. Ascending equals. Oh, what could be the issue here? Name false is not defined. Let's remove it and type it in again. False. It should accept it now. Okay, we have something like this. This is exactly what we want. If we go back again to the question, it says which agent have the highest success rate in closing, calls, right? Or deals. So we can now see here, Samuel Smith has the highest, which is 90.55, followed by Lawrence here, 90.22, and this one, 90.05, and the lowest one is actually 19.54 right in here. Isn't this beautiful? Okay, you can see how easy it is for you to come up with all of this. So let's see which is next. All right, this is the last question. Over here it says, are agent ratings, correlated with all outcomes? E.g., higher rating leads to more successful calls. So we want to check if higher ratings leads to more successful calls or closing deals whatsoever. So we're going to use what we call, I think is a plot box chart, something like that. So we have the library that actually supports us to actually create that right in here. That was why we actually imported those particular libraries right in here. It's very important. So if we now go down right now, we already have here, is very important, our agent full name. And if we go down here, we have actually converted this particular, I think, let's see. So agent rating, it has been converted here. Agent rating has been converted here. We're going to use it. So if we go back here now, we can still use it without redefining those particular ones any longer. So what do we do right now? We're going to be creating a binary variable for outcome. So let's see how we can do that. So over here, I'm going to do here so from 1 to 0, or from 0 to 1, either of it. Okay, now how do we go with this? So I'm going to do here df, so call underscore success. So call success here is going to be more of a new column. So now we're going to do equals np. If you see np here, quickly go all the way back to the libraries we actually imported, and we're talking about this particular numpy right here. So we're using numpy to get this done. So going back down right now, as you can see here, this np, I'm going to do dot where the earth. So we call the column call underscore outcome. So where the call outcome here is equal success. So we have to use this. Okay. Now, I'm going to stop it this way and explain this to you. So what we have done right now, we actually say, okay, we have call success, right? So for the call success right now, we now say, okay, where the call outcome is equal success, we want you to actually give us 1. If the call is successful, we want to attribute it to 1. Otherwise, attribute the calls that are not successful to 0. So any call that is abandoned is going to be 0. Any calls that are some kind of under fail is going to be 0 as well. Only successful calls will be attributed to 1. That is what we have just done right now. You get it right now? So let's see if we can, should we run this? Let's do df and see. So you can see we have call success. This is the column we have added. No, 1 here, 0, 1. If we keep going now, you see 1, 1. So let us look at 1, 1, what they are. They are all under successful. So fail, fail, fail here. If we go back over here right now, we can see 0, 0, 0. That is exactly what it is that we want. So we have added a new column right now. So what is the next thing we have to do to get the kind of visual we want to create, created? So the next thing now is to calculate the correlation between agent rating and the call success. So don't forget to add here okay, how do we go ahead and calculate this? We can actually call this new variable correlation. So equals df. So inside here, we're going to do agents underscore rating, comma, and their calls. That is called success, call underscore success. I hope you have not forgotten this particular call success right here. This call success is the new column we added that has to do with 1 and 0, right? So once we have added this right now, we're going to do here dot so over here, we're going to do 0 and 1. Okay, let us break this down. Over here, we have a new variable, and in it, we have df agent rating and call success with this particular function right in here. So what it does now is it's going to be calculate the correlation matrix between the agent rating and the call success, right? So don't forget that the call success, when any call is successful is 1, when a call got failed is 0, abandoned calls will actually carry 0 as well. So the correlation measure the strength and the direction of the relationship between two variables. So now here we go. So when we have +1, it's going to be strong positive correlation, both increase together. So when we have -1, that is going to be negative correlation, and when we have 0, mean no correlation, right? Don't worry, if you don't understand all this, when we display the chart, you now see what it is that I'm talking about. So we're now going to do here. So over here, let us create our box plot. So to get that done now, it's going to be plt.figure. So which means we're setting the size of our chart. So fig size. So this is all what it is for every single chart you want to create. So it's going to be setting the height and the weight now. Let's do weight should be 8 by 5. So set it to 8 by 5. And over here, we're going to do SNS dot So if you want to understand where this particular SNS is coming from, go all the way to the libraries we imported. That is going to be your seaborn right in here. Can you see that now? Your seaborn. So here we're going to do dot box plot x equals df. So now we're going to set the x-axis and as well the y-axis. For the x-axis right now, we're going to set the call success underscore success. Now for the y-axis, so y equals df. So for the y-axis, we set agent rating. You get it now? So if I now go ahead and run this, let's see if we have any error. So here we go. We have this particular, chart here. So maybe a question will be like, why are we having this here? If you want to avoid having this, what you can do now is just to do plt.show, and it will remove it away from here for you. So you don't have something like this. Okay, let us quickly look at what we have right now. Over here we have 0 and here we have 1. Before we go into detail to explain what this particular chart is all about and if this question is being answered, we have to make sure we convert this 0 to unsuccessful and 1 to successful. You get it right now? So how do we do that? We have to come over here. So let's do here. Okay, beneath it now we're going to do plt.x ticks. So ticks here where it equals 0 and 1. So what do we want to do? We want to label where it is equals 0. We want to actually labels it to be not successful, right? So comma. So wherever it is actually equals 1, we want to label it to be successful. You get it now? So we can go ahead and run this and let's see what we have. So if you check it right now, instead of first having 0 here, we now have not successful and successful. This is what we have. So let us now add a title to this. So it's very important. So over here we do plt.title. So the title now, we're going to use f string. So f. So over here inside it, we're going to do correlation. So this curly bracket here, we're going to do here think I have issue. So, oh, sorry, we flopped here. Is title. So that's T here. Let's run this again. Okay. this correlation here is not defined. So it's talking about this one. So maybe I might have misspelled it. Let me copy it from here, so we can actually paste it over here. So now we run this again. Okay, fine. Okay, so this is all we have to do. Let us now look at what this particular chart is all about. It's not everyone that will understand this particular kind of chart right here. So if you look at it right now, this particular chart is a very technical chart that you don't just give to somebody who does not have the technical know-how to read it. So the chart is a box plot showing, the distribution of agent rating for successful and unsuccessful calls, as you can see it beneath right here. So the correlation coefficients right now, which is this particular part right here, pay attention to this particular 0.003822 right in here. So what does it do? It suggests a near zero correlation between agents' ratings and call success, right? That is what it does. So the major interpretation of this particular chart is that agent rating appears similar for both successful and not successful. You understand? So if you look at it right now, it appears to be for both. So this is actually telling us that success calls does not necessarily, high rating does not necessarily means it's a success call or successful calls. So if you understand what I'm saying, so it simply means agent rating do not seem to be correlated with call outcomes. If the rating is high or low, it does not actually, correlated with call outcomes. A higher ratings do not some kind of necessarily lead to more successful calls. So if that would have been the case, maybe over here would have had this one not to show up, or even though if it is going to show up, it's just going to be something very small. That is how this particular chart is. So this suggests that factors other than agent rating might be influencing call success, right? So we cannot actually base, high rating to success calls or low rating to abandon or failed calls, right? So this is exactly what it is. So it's some kind of complex to read, but this is exactly what we can actually use to answer this particular question that says, are agent ratings correlated with call outcomes? So higher rating led to more successful calls. So that is not the case, because even those particular calls that are some kind of not successful, they actually still have high rating between 4 to 4.7. And the same thing to this particular one right here, to 5 rating, right? So they both have almost high ratings. So if we go over to here now, so this success, we're gonna look at this particular, this is rating here. For successful call, we have this one. It's actually rated 5. For failed calls is 4.9. So these failed calls might not be 100% unsuccessful. Maybe something just led to it, and the caller is still some kind of a bit happy and rated it 4.9. So if you look at the abandoned call right now, every abandoned calls we have right here, they are not actually picked. So for that, there are no rating for them. So there are rating between success and failed calls, right? So that is exactly what you need to understand. So I hope this will definitely help someone to understand how to use Python to analyze data and create charts to just make sure you visualize your findings and make it easy for end users to actually comprehend what is going on in their business. So see you in my next videos.